Right, let's take a look at this problem. Non-overlapping intervals. Given an array of intervals with list of starting and ending indexes or like values in this list, return the minimum number of intervals you need to remove to make the rest of the intervals non-overlapping. Okay, so here this can be removed. The rest of the intervals are non-overlapping. You have to remove the overlapping ones, right? So what are the cases we can face? Maybe if we sort this, we have something like this, right? And that's 1, 2, 1, 3, 2, 3, and 3, 4. Okay. So the rest is not overlapping. When I sort it like that, I can. So the second one. If their start time is empty, I just immediately delete that second one, because when it is sorted, the second item's second thing should be greater than or equal to the previous end time. So okay, if that's the case, we just remove that. And what if we have something like 1, 2? Let's say that this was 5, which is here. You can either return 1, 2, 1, 3, 2, 5, 3, 4, right? Return 0. Like this should return true, but I don't know which ones I return, right? So it doesn't help me. But we can decide which one to delete. First is that we remove if it is the same, and then we store the previous end time, and then we delete that one, and the previous end time we store the previous end time if the next one, the next previous end time is the current, if the next starting time is longer than what if I have something like that, 4 and 5? In that case, I want to remove this, right? Because I want the minimum. So this is return 2. Actually, we can test it here. 4, 5. Return. This is return 2. Okay. So, how do we handle this case? So we should probably look at which one has the shortest end. Okay, just 1 second. Okay, so how do we decide in this uh, position? So since we cannot have something on the left side, it's always better to remove the one with the lowest end. So we just remove that. Sorry, longest end. Okay. So if, like I said, if start I current starts, I feel like I can even start coding this, but yeah, if current starts is equal to, actually, like while current starts is equal to the next start, we remove the next one, count increase by 1, and I should increase by 2 because we want to skip it, or yeah, move it like this, or this should be J, and here J should be I plus 1. So we just, this is the I is here, now J is here. When it is equal, we just keep going and increasing the count, and then at the end of this we just make I equal to J if like that. So if we have that actually, but if we don't have that, I should be that, and we should look at the previous one, which should be, maybe we'll look ahead. That's that might be a better way to do this. Start from 0 until the n minus 2. So I can have something like this: I is less than length of intervals minus 1, and here I should be starting from 0. And here what happens is that should be the case. If not, I should stay same. Actually, I should always stay same. I just remove that. At the end, I will have my J. J is that. Okay, we just skip this. Now J is pointing to this. So J is here. I is there. Right. Now, what happens is that I remove this. I counted it like that. Count should be 0. I counted that, I skipped it, and J is now pointing to here. Now what happens is that I check if, so if my current end is less than or equal to next start, then maybe I just make it like this, because in those cases I should not go in and increase I by 1. But when the current end is lower than greater than the next one, then what I want to do, like if I had this, I want to remove the one with the shortest, like best, like how do I, like the one with least end here. remove the one with bigger end time. So it means that keep last like current, yeah, I mean, I'll deal with that. So just here at this point I remove that. If I had this, I remove this. And then yeah, here later on I have again similar ideas. Basically we just remove the one with the biggest end time, and then we iterate over, and that's basically it. And so if this is like also 5, I should also like here increase the count by 1 because we have to remove one of them, and otherwise we don't increase the count, so it will stay the same. So if the current end is greater than next end, then it means that current end, okay, let's assume that we have this I is pointing to here. In this case I basically want to move my pointer to next one. Maybe I can just previous, I can have previous one like that until the end. I think that makes sense. Here I have like, I need the previous end, right? That's it, because I don't care about the previous start when dealing with or previous. Do I need it? Yeah, actually I need it. Previous end should be 0 and 0, I think. Yeah. Okay, I feel like I'm getting somewhere. So basically this is previous start. If previous start is equal to current start, and this should be current start, which is actually here, current start, current end should be equal to intervals I and 0, intervals I and 1, and this is current start. If they are equal, then we just have to, if they are not equal at the start, when it is 0, I come here, previous end, current end is, so previous end is current start. So previous end is 0. It is not greater than that, and so we just skip it. But I have to. Actually, I'm changing the previous at the end. So my previous start, previous end should be equal to current start and current end. Just change them like this when I don't go in this. So my previous is now, if they will become 1 and 2, this, maybe let's make it yeah, like that. Right, so here I remove the bigger one, which means that if the current previous end is next end, which is current end. Okay, so previous, let's say that I have previous as I wanted. So previous end, if it exceeds, like in this case, the current start, yeah, like this one. Actually, it looks like I don't even need this. Yeah, I feel like I don't even need that. Because here, the previous... Okay, let's see. 1 second. Right, so let's take a look at this again. So, if the previous event is not ended and the current started, in that case, we just want to check if the previous end is greater than the current event. I just want to remove the previous one. So my current end will be the same, but if otherwise, if that's the other way around, in that case, if the current end is greater than the previous one, previous one should be... So if the previous end is greater than the current start, if the previous end is here, is greater than the current start, yes, then I just want to do that. Else, it means that the previous end is smaller than or equal to current, which is fine, which will be alright. So it means that I basically want to, now current will be that, and I will just keep going, increase I, and yeah, it will just happen like that. And then otherwise, if the previous end is current start is less than previous end, there are two possibilities. First is this one, okay, this one, and this one, we basically check if the previous end okay, so if the previous end is greater less than current end, in that case I should the previous should stay. I should increase the count, pass, and else if they're equal it doesn't matter. Yeah, if they're equal we again pass, but if it's the other way around, if the previous end is greater than what we have, if it is something like this, or maybe just put it like this, if you have something like this is like the previous one, in that case we want to remove the previous one, so the current end should become what we have. And since we have to pass in this case, we just have to change it in this particular case. So if this is equal and so it happens like it goes on like this, and in this case we don't do anything when the previous, so if the previous end and the current start, if they are equal, then we just keep going, so we don't go in this. So I feel like this is kind of way to solve this problem. I just want to return the count at the end. All right, it works. Can we test the other cases? All right, they also seem to work. So there were two cases, and I think I covered them all like that. I didn't need this. Okay, right. So let me submit and see if it works. Okay, we have a problem, and that is when we have this, I basically have to, so when I sort this, let's see, I forget to sort it actually. Yeah, that's my mistake. Yeah, intervals that sort. Yeah. Okay, now it works. Let's try it again. Oh, yeah, we have the cases where when it's negative. Let's print the intervals and see what we missed. So here we expect 0, but we have the, I guess, print count. Actually, just okay. We just go in here, and when is that? This should be I. Okay, so at the start, I go in this because my previous is, oh, okay, all right. So my previous start, this should be float minus infinity. Actually, yeah, that's why I think I had a problem. Let's submit it again. Actually, that was a mistake there. All right, it works. I think it went smoothly. Not that bad. What's the time complexity here? Maybe write that one and then submit again without print. Maybe then I can have a better runtime. So the time complexity is just this is just O of n, and do we require additional space? Let me see. No, I just use the previous and current nodes, current things. So here it should be just time of n log n. Space should be also over. So let's see now. It should be better than the previous one. Yeah, it is much better than the previous one with time and memory because yeah, I wasn't printing. So all right, so that's my solution to this non-overlapping intervals problem. So the key point was to determine how to behave and what to use for that behavior. So when I understood that I had to use the end, um, like the end times, then it was much easier, and it was all about if and else statements after that. And then I was using these two these variables to hold the previous and current times to decide, and that was basically it. All right, so that's my solution to non-overlapping intervals. It was pretty nice problem actually. I like this one. Okay, so that's it.